Okay, this is question 10 from January 2022, P1 paper. Looking at this question, we can see this is a graphs and transformations question. Let's have a quick look at it. So it says y equals 1 over x squared minus 9. Can we sketch the graph of that? Right, so what do we have as our expectations for you if we're doing one of these? Put that there. I've got my set of axes then, y and x. Pretty much as a minimum, we would expect you to know what a reciprocal graph like y equals 1 over x looks like. For the stronger candidates, I pretty much have a minimum expectation that that can translate to y equals 1 over x squared. That would be a piece of knowledge that you would have straight away. So when I'm doing this one up here, y equals 1 over x squared minus 9, I'm pretty good to go with this, that all that's going to happen is this graph is going to drop down 9 units here. So if it's going to drop down 9 units, I'm using my knowledge of the original function to end up with, let's pull that over a little bit, but to say then that the asymptote that I originally had at y equals 0 is now going to be there at y equals minus 9. So I've got the asymptote. These ones, if you want to make them go up there now, you can do. What does it say? It says show the coordinates of any points of intersection with the coordinate axes and clearly states the equations of asymptotes. So I've got my y equals 9. I should remember I've got another asymptote here going through at x equals 0 as well. So those are the two asymptotes. So I did all of that by knowing an original graph and then just translating it in some way. However, it's now generated these 2 points here where we're intersecting with the x-axis. And in order to do that, what I'm going to have to do is to say at y equals 0, what's my function? Well, my function is y equals 1 over x squared minus 9. If I now solve 1 over x squared minus 9 equals 0, that should give me these two values up there for what the x values will be. Pretty standard stuff that we'd be asking you to do. We ask you to know some of it by doing a transformation of a graph and then the other bit by doing a little bit of algebra. Here, just tidying this up then, we get that 1 over x squared equals 9, which means that x squared equals 1 over 9, which means that x then is equal to plus or minus 1 over 3. Go back to my graph, 1 over 3 and minus 1 over 3. So quick check, have I answered everything that I needed to do there? There's my asymptotes, there's those values. Yeah, I've got everything that I wanted. What I might do actually on this one is just here write down to make it clear, more than anything because it's not great on the graph, x equals 0, y equals minus 9. I don't think that's a bad little hint there, especially for the x one as we're going through. Okay, second part says, another curve, D, has the equation y equals kx squared, sorry. Given that C meets D at 4 distinct points, find the range of possible values for k. When I originally looked at this, because I wasn't concentrating, and I said, right, okay, there's going to be my quadratic. Oh, I can only see it meeting at 2 points there. And it took me a little bit of time. It's a question 10. If you're in the exam, you might have time to go back and look at this to suddenly realize, no. What's actually happening is we're getting something like that. That's still a quadratic, but now I do have 4 points where they're meeting. So that's telling us, giving me a little bit of insight before we get started. K is going to be negative when we're actually going through and doing. K cannot be positive, otherwise it doesn't work. You don't need to have that on there. We can just do it all algebraically. So for part B, I just want the curves to intersect. So curves intersect when 1 over x squared minus 9 actually equals kx squared. Okay, so we've got to solve this. Simplest thing to do, multiply everything by x squared first of all. Let's get rid of the fraction on the bottom there. So I'm going to end up by that if I multiply everything by x squared. Right, this is an equation that I've seen before. Let's get everything over to one side. I've got kx to the 4 plus 9x squared minus 1 equals 0, and that is a quadratic. It's a quadratic if you let u be equal to x squared. So if you let u be equal to x squared, I've got ku squared plus 9u minus 1 equals 0. And then when we get to these situations, hopefully this is fairly straightforward to you. If I want this to have roots, then I need b squared minus 4ac. It's discriminant work, isn't it? I want b squared minus 4ac to be greater than 0 to get roots there. So if we do that, we get b squared is 9, so that's 81. We get minus 4ac is minus 4 times k times minus 1. So that's going to be plus 4k is greater than 0. Once we've got that, then we just need to rearrange all of that to see if we can solve it to get our answer. So doing that, so it gives me 4k is greater than minus 81, so k is greater than minus 81 over 4, and then as I said from my original part here, when we're looking at it, k can be greater than minus 81 over 4, but it has to be negative, so it has to be less than 0, because of what we said previously when we were looking at it, was that when we've got our values there, it has to be a negative graph as we're going through and working it out. I took b squared minus 4ac to be greater than 0 because I didn't want just one set of answers, did I? I wanted 2 sets of answers, which would then lead to 4 sets of answers. I couldn't have a repeated root there. Okay, hopefully that all makes sense.